Okay, so now let's start discussing the functional groups. So the first functional group we'll talk about is an alcohol. So, yeah. Now an alcohol is generally represented in this format. Here, the OH group is what we call an alcoholic group. Now, an alcohol has two ways of being represented in a IUPAC name. And so the first way is by a secondary suffix. So this secondary suffix is all. So an example for this would be ethanol, this all right here. That's one way of naming this. A second way of naming this is by using a prefix. And we only use a prefix when there is a functional group present in the compound which has more priority compared to an alcohol. So I didn't tell you the priority order of the groups yet, but after we discuss all the groups, then we'll see the priority order. But just as of now, remember that if there's a higher priority functional group in the compound, then you would use the prefix instead of a secondary suffix for alcohol. So our prefix here would be hydroxy. So that's pretty much it about an alcohol. Now let's get on with the second type. The second one is so our ethers are represented in this form where there's an alkyl group, an oxygen, and another alkyl group. So this oxygen right here is what we call an ether group. And that's what really tells us that this compound is an ether. So when we're naming an ether, we don't really use a suffix or a prefix. We tend to use, we use a prefix sort of thing. And this name, or the naming of this, would be in the form of alkoxy, alkane. So this alkoxy is talking about the shorter chain, or the shorter group, and this alkane is talking about the longer group. So that's how we would represent an ether in this scenario. Okay, so now let's talk about ketones. So ketone groups are represented to us by this functional group. Now this group right here is what we call a ketonic group. So this group right here would be our identification method to figure out whether a compound is a ketone or not. So now the ketone has a secondary suffix of -one, and if there's a higher priority of functional group compared to a ketone group, then we would use a prefix, which would be oxo. Now, basically those are the two ways of naming a ketone. Now let's move on to an aldehyde. Now when we're talking about ketones, the second thing that comes to our mind is an aldehyde. So aldehyde and ketones are pretty much linked up together, which is why we have a chapter combining them both together. Anyway, so aldehydes are represented to us by the CHO, RCHO. And by the way, the CHO is in this format. And so this group right here is our aldehydic group. So that's our identification method. Now, we've got a lot of different ways of naming this. One of them is by using a secondary suffix, which is al. So methanal, ethanal, propanal, etc. Now, there are a bunch of other prefixes that we could use. Our prefix here would be formyl or oxo. Let me just... And they're used in different cases, and we'll talk about those cases later on in this video. We could also use another suffix, which we call a special suffix. And this special suffix is carbaldehyde. Oops. So that's our special suffix. Now these are used in different cases. Now for the special, we'll talk about the prefix first. So our formyl and oxo prefixes are used when the aldehyde group, or this CHO group right here, is not directly attached to the parent chain. Now, there are many different examples for this. One of them in which the parent chain contains more number of, has more number of substituents or functional groups or multiple bonds compared to a chain which has the the aldehydic group. That's when we use this formyl part. Now, oxo is used when the CHO is included in the parent chain, but there is a more higher preference functional group compared to an aldehyde. We'll get to the examples in a little bit. But a special suffix is used when there are three CHO groups directly bonded to a parent chain. Then we use the carbaldehyde suffix. So if you want any examples, let's talk about the examples. Oh, also I forgot to mention an aldehydic group is a terminal functional group. So whatever our compound is after the CHO group, it does not continue. So it's a terminal functional group. So now let's get to the examples. So this is one of our examples right here, okay? So what I want you to do right now is pause the video and figure out what the parent chain is and how you could possibly name this compound. So I'm assuming that you paused the video, so let's get to work. Now, what could our longest parent chain be? Well, it could be, here we'd have a different way of handling things, and that's because there are three CHO groups. And since there are three CHO groups, we won't consider them as, part of the parent chain. Instead, they would be considered as bonded to the parent chain. So in this case, I'm considering our parent chain to be this right here. That would be considered as our parent chain. So how many carbons are there on our parent chain? It's 1, 2, 3, and 4. So this would be bute something. Basically, we figured out that our root word is bute. Now, since this comes as a suffix, these 3 CHO groups, which are directly bonded, as I've mentioned before, this special suffix comes into account when 3 CHO groups are attached directly to the parent chain. That's when we use the special suffix of a carbaldehyde. So now we've got 3 CHO groups which are directly attached to the parent chain, and hence we have to use the special suffix. So we don't need to worry about a prefix in this case. Now, when we're looking at the parent chain, which is this, do you find any sort of double bonds or triple bonds? No. So here we're going to use ane. So we've got our primary suffix down and our root word down. Now all we have to talk about is the special suffix in this case. So after getting butane down, I'm going to move this to the side a little. After getting butane down, we're going to talk about where these, what are these called? Where these functional groups are located. We're talking about the lowest locant set. Now, if we're talking about the lowest locant set, I already wrote one of the possibilities. So the other possibility would be this. So one of our locant sets are 1, 2, and 4, and the other locant set is 1, 3, and 4. So obviously our lowest locant set is this. We do not consider this here. So what we're going to do is we're going to write butane 1, 2, 4, and since there are 3 CHO groups, we're going to write tricarbaldehyde. So that's the IUPAC name of this compound right here. And that's an example of how we would use our special suffix of carbaldehyde. Okay, so here's another example regarding aldehydes. So let's get started. So when we're looking at this compound, we see that we have 3 aldehydic groups. However, in this case, we will not use the carbaldehyde suffix because of one simple observation that we can have in this compound. And that observation is that, all 3 of these aldehydic groups are not directly attached to the parent chain as shown in this example right here. So if you observe carefully, let's compare these two. This is one aldehydic group, which looks pretty similar here, and the other aldehydic group, which is also in a similar position. However, this aldehydic group in both of them are different. Why? Because here we've got an extra CH2 group. An extra carbon is present there, which means that this aldehydic group is not directly attached to the parent chain like this aldehydic group. This aldehydic group is directly attached, while this is attached to the parent chain with the help of a second carbon. So that's why we won't use this carbaldehyde suffix right there. So we're going to approach this in a different way. So as I've mentioned before, we've got these two to use in this case. Actually, we're going to use both this and this, but we'll see in what way. So let's zoom in and we'll check this out. Okay, so let me erase all of this. Okay. So now what we're going to do is that we're going to identify the parent chain. Now if you look closely enough, you'll just directly realize that our parent chain is this. There is a second option of going with this parent chain, but they are identical. I think 1, 2, 3, 4, 5, 6, and this is 1, 2, 3, 4, 5, 6. Yeah, so they're both identical. So we're just gonna go with the red chain for simplicity purposes. It's easier to follow that. Okay. Now what we're gonna do is that we're gonna find the locant, the least locant possible, right? So we're gonna label the locants as 1, 2, 3, 4, 5, 6. That's one set. And the other set is 1, 2, 3, 4, 5, 6. Now, what are our locant set? So, let's see. So, for this aldehyde group, we've got either a 1 or a 6. And similarly, for this aldehyde group, we also have a 1 or a 6. So, obviously, our locants are not determined by these two aldehyde groups. We have to look at the other aldehyde group. Now, this group right here has a locant as either 3 or 4. Now obviously we have to go with the lower one. So our lower one is 3, and hence we're going to go with the lowest locant set, which is 1, 3, and 6. Our other locant set is 1, 4, and 6. Obviously this one is the one that we have to choose. So we're going to go with that. We're going to go with the red locants. So we'll just erase the blue locants. And here we go. That's our final decision about the locants. Now what we're going to do is that we're going to take a look at the parent chain and where the groups are located at. So if we take a look at the first and the 6th carbon, we've got an aldehyde group which is directly attached to the parent chain. And now since these are directly attached to the parent chain, we can use our secondary suffix, this one right here, which is al. We'll use that right here. So I'm just going to write the suffix that we're going to use for my reference. So we're going to use al here and al here. Now, this is also an aldehyde group, but it is connected to the parent chain in the means of a single carbon. So this entire group right here, this, we will call it as a 4-methyl methyl. So, as I've said, we had to use a secondary suffix and a prefix in this second compound right here. Now, for the prefix, we use the prefix 4-methyl when the aldehyde group is not directly attached to the parent chain. And we use the prefix oxo when it is directly attached to the parent chain. Now, if we take a look at this right here, 4-methyl methyl is used because this aldehyde group is not directly attached to the parent chain. In fact, it is attached with the usage of a single carbon. And since the root word for a single carbon is meth, we use methyl. So this entire group combined would be named as formyl methyl. So now let's name this compound using this information. So when we're naming this compound, we're going to start with the prefix. So in our case, the prefix would be formyl methyl, but before that would be the locant. So our locant is 3 formyl methyl. That's our prefix. Now comes the root word. So our root word is what? How many carbons are there in the parent chain? That's 6. So here we use hex as our root word. And are there any double bonds or triple bonds present in our parent chain? No, right? So that's why we use the primary suffix of -ane. Now, all we have to take care of is the secondary suffix. Now, the secondary suffix would be the locant followed by the suffix. So what we're going to do is this. One comma 6 dial. Because there are two aldehyde groups, we use the word di in front of al. So yeah, oh, and also don't forget this. So that's how you name this compound right here. Also, speaking of which, I forgot to put a dash here as well. So yeah, be careful with all of that. So here we are. That's that for the aldehydes.